All right, so quiz one key. This first one, rank the bonds to carbon below from most reactive to least reactive. So again, when you have these ranking things, find something that's the same and then find what's different. So the carbon's the same for all of these. And you have a sulfur, a selenium, and an oxygen. So you want to see where they're at in the periodic table and what their differences are. Right, and so those differences, they're all in the same column. So the major component there is size. Right, so carbon stays the same size, oxygen, sulfur, selenium. So which one's going to be more reactive? The carbon-selenium bond is the most reactive because it has the least amount of orbital overlap. Right, they're not sharing electrons as well. Whereas a carbon and oxygen are closer together and they can share electrons more. So that's going to be the least reactive. So it's just based on size. This one, Lewis dot structure, Scholar work, including all lone pairs, formal charges. Hint, chlorine is central and expands as octet. That was a big hint. So you put chlorine in the middle, put the oxygens all around it. If you see an H, they're not, hydrogens usually are not bonded to the central atom. They'll be bonded outside. So you got the OH out here, and then to make sure there's no formal charges, all these oxygens had to have two bonds, right? And I said chlorine is central, but expands as octet, so it doesn't have any formal charges. So this is the final structure. For this one, type of hybrid orbital. So again, you ask yourself, how many pi bonds does this nitrogen have? It has one pi bond, so it's sp2 hybridized, which means its lone pair in this case is in an sp2 hybrid orbital. Hybridization of that nitrogen is sp2, right there. What hybrid orbitals form the sigma bond between the nitrogen and carbon? So this nitrogen is sp2, this carbon is also sp2, so both of them use sp2 hybrid orbitals to make sigma bonds. Here, we're just looking at, again, what kind of pi bonds they have. We hadn't learned about resonance yet, but wouldn't have mattered. Carbon with a pi bond, one pi bond, sp2. Oxygen with one pi bond, sp2. This carbon has two pi bonds. It would be sp. We did that on a workshop. This carbon has no pi bonds or lone pairs, so it's sp3. What hybrid orbitals are forming the bond between the bond below indicated by the arrow? So that one right there. So this carbon is sp2 hybridized. This one is sp, right? So the sp2 hybridized carbon uses sp2 orbitals to make a sigma bond. The sp one uses sp, so it's sp2, sp. Give the molecular formula for the statin drug, C20H20. So a lot of times we miss some hidden hydrogens along the way. Don't forget to add your lone pairs in, all those kind of things. You have a periodic table and draw lone pairs in. Another good example of, well, this isn't that much different than we did before. So this is the same kind of question, almost exactly the same question that was on the practice exam, right? Oxygen has a lone pair, you're forming a new OH bond. So I said add lone pairs, both starting materials and products. Assume all full octets. Two lone pairs, one lone pair moves electrons to form a new sigma bond between oxygen and hydrogen. This NH bond breaks, those two electrons go to the nitrogen, end up there with the right things.